Hi everyone, welcome back to Geeks for Geeks. Today we have another DSA mock interview. Our guest for today is Anupam Pandey. So I'll be interviewing him. So let's quickly call him and take a quick intro of him. Hi Anupam, can you please introduce yourself?
Yes, sir. So good evening, sir, and everyone. I am Anupam Pandey. I am from Information Technology branch, PE third year from the College of IIT DAV Indore.
Okay. So as you know, today we'll be having a mock interview with you. So all of you
Yes,
can just quickly give us a +1 in the chat if my voice is clearly audible and everything works fine, so that we can quickly start the interview. So all of you can quickly like the video and quickly give us a +1, and then I'll be starting with the questions.
yes, sir.
Okay, so I'm just quickly waiting for your responses, audience. Okay. So Anupam, you can quickly share your screen. If you look down, so there is a share option. So from there you can quickly share your screen. Okay. So now let's start with this. So in the private chat, if you will look at the private chat, so I've shared a question link with you. Just quickly have a look at it. Yeah, you can open it. Okay. So quickly just log in to the GFD account.
Yes, sir.
Then I'll explain the question to you as well.
Yes, sir.
Okay. So let's quickly start off with this question. So the question is that I'll give you a matrix and you have to search in the given matrix. Now what you have to search? So basically I'll give you a matrix and it has some specific property. You can scroll up so that I can read the question for you quickly. You can scroll up back. Okay. So I'll give you a matrix that will consist of, which will be of size n cross m. It will be consisting of integers, and every row and every column is sorted in increasing order. Is that clear to you? This statement
Yes,
is
sir.
clear that every row and every column is sorted in increasing order, and you have been given another number x. So I'll give you another number x, and what your task is that your task is to find whether the given element x is present inside the matrix or not. Is that clear to you?
Yes, sir.
Okay. Okay. So like, how will you approach this particular problem?
So,
Audience can
sir,
also tell me if they are clear with this question. Yes, Anupam, you can go ahead.
yes, sir. So first of all, sir, I will tell you about the brute force. So like, if we are given 3 cross 3 matrix, so like we will linearly traverse through each row in each column and check for and for give a for loop, and we will check for each and every row in column that if that element present or not. But this one, the time complexity will be n cross m, that we the very more time complexity will be there. So ये करने की वजह हम ऐसा कर सकते हैं इस क्वेश्चन में कि वी कैन अप्लाई, as we can know, you use one property of that question is that we, as we have given the second row, the elements are increasing order and the first element of the next row is greater than all the elements, so we can apply binary search on this question, and such as in
Okay.
such that like uh, like in the, if our diagram for this element 62, like if we take any middle element like 52, and we will check that if 62 is greater than 52 or less than 52. As you can see that 62 is greater than 52, so we will discard this first row and this first element, and then we will search only in this area. And after 52 and 16, between 52 and 69, we take another middle element, let's just say 57, 57 or 60 something. 57.
So where are you applying your binary search?
Yeah, yes, sir. I
Like
will
how
apply binary search in that in this whole matrix.
in the whole matrix?
Yes, sir. Sir, there's two
How?
ways to apply. Sir, is there two ways to apply? Like first of all, I can store this matrix in a array, or I can also search by first element also, rather than applying. Like I will take first element like 44, and I will check if that element is less than 44 or greater than 44. Like first element of every row, and then
Okay,
search
so
in that.
how much time will you take in that case if you store, you are saying that generally you are saying that what you will do is you will store all the elements of the matrix in an array, and then after that you will apply binary search, correct?
ठीक है सर ऐसा firstly if I store the all the elements in an array it is n cross m and if binary search is n log n time complexity will be less in this case but it will have extra space complexity if I store it in
What
another array.
will be the time complexity of your binary search approach that you are suggesting?
Login sir.
Are you sure?
Type of-
Because like you are applying the binary search on the whole all of the elements at single point of time. You are storing all the elements in a matrix, correct?
yes
So
yes
how
sir.
many elements are you storing in the matrix?
So can you pardon please sir, please pardon sir.
I am saying that how many elements are you going to store in your matrix, like in your array?
Yes, sir. First of all, I will store. First of all, I will store all these elements in a matrix, like all the 9 elements, as you can see in in this example. And after that, I will take out the middle element, like from n by two. So the middle element will be fifth element will be the our middle element high minus low by two,
Okay.
and then after 52, I will check if that element is greater, mid is greater than our target or less than the target.
But in this case, if you do that particular thing, so are you sure that your complexity will be n log n for binary search?
But so time complexity will be less, but space complexity will be more. So.
Are you sure it will be n log n if you store all the elements of the matrix into an array and then do the binary search?
M cross M, you can say so. M cross M
What
log
is the
N.
total number of elements that you will be storing in the array?
Yes, sir. Pardon, sir.
What will be
Total
the
number
total number of elements that you will be?
no 9 elements. Sir.
So that is n cross m, no?
Hmm. M cross M log N cross M. Sorry, sir.
So that will be more high,
Yes,
correct?
sir. So, sir, matlab, we can simply also search like as we said the first one. I will tell you different approaches what we can apply in these questions.
But since it was sorted, so you suggested a binary search approach. So you think that something better can be done?
So better than binary search.
Better in binary search,
So better in binary search. Once again, sir, let
at
me.
least better in binary search.
Yes. Can I have for 5 minutes?
Yes, whatever you are thinking, you can think out loud so that we can understand that what is your thought process as of now.
Mij. Um, so, like we have to decrease the time complexity rather than searching whole. We have to search by parts. So that's why I think about that binary search approach. Now, other than that, yeah,
Can you think about binary search more smartly if you're suggesting for binary search?
yes, sir. Yes, sir. Yes, sir. I know I got it, sir. So, like if there is n cross m both are same numbers, like you have 3 cross 3. So, I will take the number which is the middle element, like we have 52. And how will I find which will be the middle element without storing it in another array? How in that same 2 cross 2, how will I know? So, where 1 cross 1 means at the index 1 cross 1, I will take 1 cross 52 as the middle element and then see if I have to decrease the indexes. Now, if it is present in the left side of that element or right side. Hmm,
Uh,
I think.
so does it improve your complexity?
So now, as we can see now, rather than searching on the all 9 elements, I have to search it only like we can see 62 is greater than 52. So I have to search only in the right half or right side right half of that, only the below row and the second last element of the second row.
So you for your approach, what will be the time complexity?
So now it will be half n by two, and it will decrease by two as you can see. Like if a 52 and 69, like one, two, three, four, five elements, and then we will intersect half of, then means we decrease the searching area quite.
So can you tell me what will the time complexity for your approach, whatever you are suggesting, for the number of elements that you are taking?
So if we can take 9 elements, so 9 n by 2, n cross m by 2. I'm confused.
Just think about it for a second, and then tell me what will the time complexity. Others can keep on suggesting their solutions in the chat. I'm looking at the chat. Some people have suggested the right thing also.
So time compression should be n plus m. Okay.
No, you like you're suggesting buying search. So can you think in terms of buying search? What will be optimal time complexity if you apply buying search smartly?
Yes, so means I know that this is the best approach, but unable to tell it about that. So think about it.
Can you think about buying search in a more smarter fashion for this question?
So,
Like looking at the
I have to ask you one thing.
information.
Am I going in the right direction?
Currently, your buying search approach is not going in the right direction as of now. You can think about it a bit more smartly.
Means like so, its optimal approach will be binary search only. No? So using binary search only.
One solution
The
you
best.
can suggest using buying, but there will be one more optimal solution. But currently, I'm asking you about the buying search solution only because you have suggested that. So I'm asking that whatever buying search solution you have suggested, can you optimize it for a little bit more?
I can little bit more optimize it. Okay.
Whatever you are thinking, you can think out loud so that we know that what is your
Yes,
thought process currently.
yes sir. Like I am thinking about that like कि जैसे हम ये इसमें देख रहे हैं कि हमारे पास 3 रोज 3 कॉलम्स है जैसे 1D में तो हम लोग सिंपली स्ट्रेट फॉरवर्ड बाइनरी सर्च लगाते हैं और वो बाइनरी सर्च को मैं किस तरह से लगाता हूँ जैसे मैंने 52 वाला देखा था उसमें आप बोल रहे हैं कि थोड़ा सा उसको और थिंकिंग सो लेट्स सी
Okay, so I will give you one hint. Okay, I'll give you one hint. Where do you apply buying search? When the elements are given in sorted fashion?
सर
Yes
कैन
or
यू
no?
प्लीज पार्डन सर
I am
सर
saying
प्लीज
that
पार्डन
when
सर
do
कैन
you
यू प्लीज
apply buying search? When do you
सर वी
apply
अप्लाई
buying
बाइनरी
search?
So, if like in this question, like mainly in searching where the data is in ascending or descending order, where is in the ascending or descending order in that cases, and we have
Okay,
to search for an element. And
so see, if you apply the buying search on the whole matrix, that makes no sense, correct? You have observed this part?
yes, if I apply in 1D matrix, it is easy, but in 2D matrix, if I apply binary search in
Okay.
the element,
So if that is the case, so can you think like how you can use the concept of buying search still because the rows and the columns, again I'm repeating, if you will see each and every row and each every in every column is also sorted. So can you think of something more better in terms of buying search only?
so one approach also I am thinking of like in each row I'll apply binary search and take and search for
Okay.
it. One approach
In
is there,
each row
but
you'll
I
apply buying search.
like in each row, first row, second row, and last row. I was thinking about that.
So if you apply buying search in each row, then what is the worst case time complexity for your approach?
Like worst case is that I didn't find in element. All the elements are in I find it in the last value. Like I have to search in all the middle elements, all the elements of that matrix.
No, in every row you are applying buying search, and there will be certain number of rows. So what will be the time complexity? Because if you apply buying search in a row, then there will be some complexity for it, and you apply buying search in every row. So overall, what will be the complexity? Any idea on this?
So in each row, like n log n plus n log n plus n log n means all the row will have any n by 3 log n by 3 means every row have three elements right now. So 3 log 3 is like that. We have to add some of all these.
3 log 3.
No, sir. That means I have to like bind the search of all threes.
Can you
So
tell
can you
in terms
please
of? Can you tell? Yes.
confirm like binary search time complexity? I'm little confused about that.
You are
And
not
login
clear with the
and
time.
login and login, sir. I am sure, but in the linear one, but in the 2D, sir, I
You are
know
not
this.
clear with the complexity of buying search.
Sir, I know, but I am just confirming. Mm,
So what is the time complexity of buying search in a linear array?
binary search and login, sir.
So then, if buying search complexity is n log n, then why don't you use a linear search? Because linear search will give order of n.
Order of n, yes, sir.
So what
Order
will
of
be the
n.
complexity of buying search?
No, sir. It is little. It is. I know it is less than the linear search time complexity.
Okay, so can you think? Can you let's say can you derive what will the binary search complex? What will the complexity of buying search?
Mm. So like in the middle, so n by two. Let we will divide n by 2 plus n by 4 plus like that n by 4 plus n by 16 plus n by 32 plus n by 64 like this.
Okay,
We will
you are
take,
saying that a geometric progression will be formed.
yes, sir.
Can you think what will be the complexity of buying search?
So log n will be there. I am pretty much sure about that. I think log
Correct,
n,
log n.
log n, yes, sir.
Correct.
Log n, sir. Yes,
Okay.
sir.
Now,
We're
if you
starting. I'm, yes, sir. बोलिए.
now now if you look in this particular example again, so if you are applying buying search, you are saying that you will apply buying search on each and every row. Okay, in the
Yes,
worst case. So can you tell me if you apply buying search in one row, then what will be the time complexity of applying buying search in one row?
like if we take in this example, every row has three elements. So log to base to n is 3. So I have to binary search in all the three
So
rows
okay, so what is three? What is three here? Three is what? Like
and divided by
in a
3, n
row,
by
how
3.
many elements are there? In a row, how many elements are there?
In that matrix, you have total 9 elements are there in the matrix.
In the row,
So
in a particular row, since you are applying buying search in a row, so how many elements are
three,
there?
three, three, three elements are there.
Uh, in terms of m, can you tell me in terms of m
N
or
by
n?
3.
Are you sure?
One second. N by m, sir.
The number of elements, like see, in there are total n rows. Okay, there are total n
No,
rows,
so n rows
and
also mean n. And in each
okay,
n
there are
rows,
total
there
n
are
rows,
and m elements. So
and there are
total
and
m,
there are
so
total
log n
m.
by m. Total m
Okay, it is
elements
what?
in each row. Yes, sir. M, log
Yeah.
m. So
So
in log
for
m.
applying buying search in one row, you will take log m time.
Yes, sir.
So if in the worst case you apply buying search for all the rows, then
Then I have to add the time complexity in all the three rows. So log.
like total number of rows is n. So for one row you are taking log m time you
N
are
log
saying.
m, sorry, N log m.
Then
N log m.
okay, correct. So can you write that approach quickly? Okay, before writing that approach, can you tell me, is there any more optimal approach that you can think of as of now? Like instead of applying by search, can you apply something else? You can just uh, like your you can just again do one thing. Just put like uh, fix your camera once again because I think it's not your face is not visible properly. Yeah,
So now is it?
yeah, it's now visible.
So another approach.
Can you think of something more optimal, or will you like to apply this approach
Yes,
only
sir,
as of now?
I am thinking about more optimal one.
Um,
The
okay,
two
so
points.
other people's okay, two pointer. You're saying two pointer approach. Like how you will apply two pointer approach here?
So like first element on the last three percent. So start with the three and six first pointer in the starting first first row first column, and the second pointer and at the end. Then
Okay,
no sir, it will
then
be binary only. Then no sir, वही जा रहा सेम में, तो उसमें भी कॉम्प्लेक्सिटी इतनी आ रही है, मतलब उसको फिर दोनों को फर्स्ट एलिमेंट और लास्ट थर्ड एलिमेंट को हम करेंगे, फिर उनका जो फिर उनका एवरेज लेंगे 3 + 69 बाय 2 करके समथिंग ऐसा सोच रहा था, बट वो भी नहीं, नहीं, one second.
okay. So can you write the code for your buying search approach that you are thinking as of now?
Okay sir.
So you will be using C++ language?
Yes sir, I will code in C++, sorry sir.
Okay. So you will be given a matrix and you'll be given n and m, that is the number of rows and the number of columns. And then you have been given the element x and you have to apply your approach in this question as of now. Because you cannot think of any better approach. Again, I will request you to please fix your camera as well.
So now it's okay.
Yeah, now it's feasible. While you are writing the code, so you can keep on telling me like what is your thought process and
Yes sir.
what you will be doing.
So first of
Okay.
all, the first for loop, then total m elements are there in each. Plus plus. So first of all, the first
So the number of rows is n here. Okay.
is number of rows are 3 and number of columns are n.
If you will look at the second example as well, so you can go through the second example.
Yes sir. 1 and 3, as in this example, we have 1 rows and 3 columns.
Yeah,
6m is
so
equal
you
to
can understand n represents the number of rows. Okay.
yes sir.
So why you have written this loop in the line number 12?
So for searching in that first in the first row,
Okay. So this outer loop will be running for the rows.
yes sir, for the first row and firstly, sir, can I firstly about that first one approach like n plus m approach, you are asking, it is asked now.
But if you can write the bind search also, that will be fine.
Okay sir.
Because you are not able to come up with more optimal solution. So if you even if you can write that, that will be okay.
Okay sir. Oh, yes, we have to search about X, no?
Okay, so first loop you are writing and running it till n.
Yes, sir. Now we will
Okay,
that is zero based induction. Okay.
just zero based indexing. Why are you calculating mid like this?
For finding out that no, sir. Directly I can take middle element. Yes, sir. So for that, in this we can take the middle element directly, but for finding the middle element, for finding the middle index of the middle element, like for that.
But are you, let's say you are at the ith row, correct? So are you properly applying the bind search approach here? For in every row, in every ith row, you have to apply the bind search, correct? That is what you're thinking as of now.
Yes, sir.
So how will you do it in every row,
So,
for every row?
sir, for every row, like first we take any middle element and check if the element is greater than that or the element we are searching for is greater than that or
Okay.
less than that, and then we will take see if I have to search on the left hand side of that element or right hand side of the element, or is it that element only.
Okay, so are you actually writing by, like, have you actually up till now, have you ever, have you up till now written the bind search code
Yes,
here?
sir, but at that time I'm little.
Are you getting my point? There are some more variables that are used in bind search, correct?
Yes, sir.
Okay. Guys, in the meantime, while Anupam is solving this question, so all of you can tell me whether you are able to solve this or not, or if you have got this as as accepted in the most optimal time complexity for this question. So you can tell me that as well. And if you are still thinking, so you can tell us about your approach. I'm quickly reading your approaches as well.
So can we, sir, once again I am little bit confused about this question. Can we move to the second question and then afterward I will go into
Okay. So you
that.
want to change the question?
So
Sure,
and then
I'll do that.
at the end I will come back to it.
Okay, sure, no problem. So let's do one thing. Again, if you will go to the private chat. So I have shared another question with you. Let's have a look at that also. Okay. Yeah. So let's quickly have a look at this particular question. Now, this particular question is saying you have to find what you can scroll up again because I'll read it for you first of all. Okay, scroll up again. And also, I'll
Yes,
give it into the comments. Just give me a second. Okay. Just one second. Just give it in the chat as well. Okay. So I've given the question link in the chat as well, so audience can also have a look at it. So what I'll give you is I'll give you I'll give you a matrix again. Okay. So I'll give you a 2D Boolean matrix. Okay. So Boolean matrix, by Boolean matrix, I mean that the elements in the matrix will be 0 and 1 only. Is that clear? The elements in the
yes, sir.
matrix that I'll give you will be 0 and 1. Now, there is some special property in this matrix. The special property is that each and every row is sorted. Is that clear? Each and every
Yes,
row
sir.
is sorted. So
Yes,
every row will consist of what kind of elements? It will consist of zeros and ones, correct? Because
yes, sir.
those are the elements that are allowed. Now every row is sorted in itself. Okay. So what your task is that your task is to find the row you are, according to zero based indexing, you have to find like the first like you have to find that particular row. You have to identify that particular row which has the maximum number of ones in the given matrix. Is that clear to you?
Yes, sir.
Okay. So anything that you have any sort of doubt you have in this question?
Yes, sir. So first of all, I will tell you about the brute force approach. Like as we can see, the n is the number of rows and m is the number of columns in this question. Am I right? So yes, sir. So the first brute force approach will be to to make us some variable and store the maximum sum in that variable. Like first of all, I will
Okay.
add a count the variable number of ones in the first row, and then store, like in this case, if the number of ones are 3, so I will store the value 3 in the sum variable. Now I will check for the next row, and in the next row I will there is 2, so I will compare, like in using max function. I will see that maximum which in it, if it is greater than the previous one, like which is stored, like in the max variable. Sorry, sir. I will store firstly make two variable, max variable and sum variable. So first of all, I will traverse the first row and see if how many number of ones are there. So in this, I have three number of ones. So the value of sum will be 3. Now I will take in the
And you will store
max.
this particular row. Okay.
Yes, sir. In the
And
I
you
will
will say that this
and
is the current row that is having the maximum. Okay.
yes, sir. First row, and then I will check in the second row and count the number of ones, and after that I will see that it have it have two number of ones. So I will compare it with the variable max. If the value of sum is greater than max or less than max. So if it is, as you can see, the value of sum is less than max, so we can the value of max will be unchanged. So now we will move to the third row third row. So in the third row we can see that there are four number of ones. So in this four number of ones, as there are four number of ones which is greater than the max, which we have seen. Max is 3 currently, so I will
Correct.
update it to 4. So and also store this, as we have to uh, output output should be the index of the now. So I will store it in a variable called int ans. I will store the index of it, and then move to the fourth, iterate to the fourth row, and in the fourth row I will check for how many number, as I can see there's zero number of ones in in that row. So the so we have traversed the full matrix, and the maximum number of ones we found in the row number 2, so we will return it there.
Okay. So how much time will you take? What will the time complexity for this particular approach that you are thinking and that you are thinking of writing?
N into m, sir, n into m.
Okay. So that will be n into m because you'll be
uh,
iterating through every cell.
yes,
Correct?
we are iterating through every cell.
Okay. Can you see again? If you will look at this particular question, if you will scroll up, so again there is one hint that is given that the rows, each and every row is sorted. So can you use that property here? That is what I'm asking from you.
Yes, sir.
And
So
audience can also tell us about their approach, like whatever they are thinking, they can also tell us.
yes, now I will try to optimize this approach. So like as you can see, the as it is in the sorted order. So
Okay.
like like first of all, I can see one approach, like if the last element of any row is ending with 0, means that whole row is this can we can discard that row, which means if the last element is 0, that the whole means there is no zero number of ones in that row.
Can you repeat your approach again?
Like I'm saying that we check for, first of all we check for all in the last column of in the last column, as we can see, I will see which row has a 0 in it. So if the last column of if the last at the end of each row, any row, if there is 0, means that the whole row is 0. So I can discard that row and not search in, not count in that, not count search in that row. So now we have, as we can see, I have to search only in the first three rows, and there are four columns.
Okay.
So now as and we will move one step more backward and see if there in second row if there is any zero in that, and third column, that like that we can see by this traversing backwards, so that we can discard
Okay, so
that.
you are saying that you will traverse backwards. Let's do it again. You are saying that you will traverse backwards in the very first row. Okay.
Hmm.
Then you will reach somewhere. If you get one, then you will move back one by one. You are saying this?
Yes, sir. And I also put a count variable and counting the number of ones in each row.
But if you will count the number of ones in every row, then overall what will be the complexity of your code?
No, sir. Like I am discarding as well. Na, like if say there is zero here in this here, for example.
Yeah,
So
yeah,
I will not search these two
correct, correct.
in that column, in that row.
Okay. So can you write the code for this approach that you're thinking of?
As you can see.
So I can see a lot of discussion is going on in the chat, and I really like this. Like Arnab and Lokesh, many people are discussing. That's really great. And Arnab, you have suggested the right thing that there is one more optimal approach for this. Okay, so that's great. Other people can also keep on commenting their approaches. Okay, Anupam, can you fix your camera again? I think it's
No,
not
sir.
working.
It is okay.
Yeah, it's fine now.
A equal to m j is the so last column basic. If one
So what are you thinking while writing the code? You can also tell us about that as well.
yes, sir.
Anupam, you can tell us like what actually you are
Yes, sir.
writing in terms of code.
As we are like I am traversing through each row backward, as I said to you, as I tell you, I am traversing each row back in the backward directions. So I am first of all starting with the last row, and I am traversing like if it is I comma m, so means it is at the last one. Yes, n should be there. N should be there.
Again, I will request you to fix your camera once again if that is possible.
So if I m is equal to zero, means I have in that case means I minus minus means I directly jump to the next in the third row. And I directly jump to the third row if the if there is a zero at the last index.
Okay.
And then yes, now I will now if there is not zero is not there in that, so
I think you have made a mistake in line number 11 that you have written I minus n there, no? Sure. In the line number
what
11.
line number
In
one.
the line number 11, you have made, you have written I is equal to I minus n, you have written in the loop. I'm not sure.
Acha, that should be equals to it. That should be equals. Sorry for that.
You can also fix the
Question
semicolon in line 11.
line number nine. Oh,
11. In the
oh.
starting of line 11, you have a semicolon extra. Anupam?
Yes, sir. It's one second. I'm looking for some. I, I think I got full for loop. Hmm. So can you give me a hint like if there is any other approach like if can give me some hint of
Okay. So see, you are still not using the thing, the concept that is given here. That is each and every row is sorted. So are you using this concept here?
so sorting, you know, in sorting. So we will see search
No,
for the.
I'm
Ah,
saying that
yes, sir, yes,
they
sir. Yes, sir.
I'm
I got it, sir. When I got it, I got it. Sir. Can I tell, sir? So
yes,
now,
sure.
got it. So first of all, we will see like in the first row, as you can see, the first number of first one is coming at the index one. If we take a zero base indexing, so one and we have four total. So four one total number of elements in the first one is four. So m minus the first occurrence of that of first one. We can see that first occurrence is one. So m minus I, we can see that number of ones will be there in the first row, and like that as you can see in the row number one, in the row number one we can see that the first one is occurring at the index 2, and the total is the index 3. So total is the 3 indexing. So yeah, so m minus I plus 1. So I have to add plus 1 as well. So rather than searching for the whole, I can think of is it correct, sir? Like see the only the first occurrence I have to see in that. So I have not to मतलब उसके बाद वाले मुझे ढूंढने नहीं पड़ेंगे. Is it correct, sir? And if it
Okay.
is
Okay.
this approach,
So you are saying that in every row you will find the first occurrence of one, and that
yes, sir.
will whichever in whichever row the occurrence of one will be minimum, that row will have the maximum number of ones. You are saying this thing?
Yes, sir. In that index, which we find the one in the at the earlier index. Yes, sir.
Okay. So in that case, what will be the time complexity? If you are saying that, basically you are saying that in every row you will apply bind search, correct?
Yes, sir.
So overall, what will be the complexity of your approach?
So in the worst case, I have to traverse it till the end in each row.
Okay.
If there is a zero ones in all zeros in all the rows. If there is only zeros.
Okay.
So, so that way the same complexity will arise. Like I have to traverse the whole row. So for that, so first of all, I can apply one check as I have tell you like at the end of each row. First of all, I'll check if there is any zero at the end. No, no.
Okay. Others can also tell us about their approaches. I can see there a lot of people are suggesting brute force approaches in terms of buying search as well. So I'll request other people to think more optimally. That is why I've taken these questions.
It's a
Yes, Anupam.
brute force approach will be like more time complexity.
No, Anupam. I'm from
So
you.
in
I'm
the worst
asking
case,
like
yeah, in the worst case, it is same and cause same time complexity will be there. So I'm thinking about something like which can avoid in the worst case. In the worst case, if there are all the zeros in zero,
okay.
then
So
same.
see, like see, you suggested the right thing, na? That see, if you think about let's say sorted fashion. So if something is given as sorted, then you'll think about buying search, correct?
Yes,
Now you
yes,
were
sir.
saying that in every row you said that you will apply Bayes search, correct? And you will find the
Yes,
minimum index of one, the leftmost index of one in every row, and
yes,
whichever row will have the one which has the minimum index, that particular row you are going to consider, correct?
yes, sir.
Okay. So I am asking, what will the time complexity of at least this approach? What will be your complexity in each
But in the
row you are
worst
applying
case,
Bayes search?
in the worst case, I'm saying it is having n cos m only na. So for example, if there is no number of zeros, well, no number of ones will be there. So I have to traverse
Okay.
the whole number,
But you are
whole.
in every row you are applying Bayes search, na? So
Yes,
in
sir.
one row, if you apply Bayes search, what is the time complexity?
In the one row, if I apply binary search, so
It will be log
I
n.
think it is constant. So
In
in
one row,
every
if you
row,
apply Bayes search,
so log. Log very constant time complexity. I'm not sure. Like
can you think
and
about
I guess
in one in a particular row which is sorted, if you're thinking of applying Bayes search, are you thinking of
yes, sir.
applying Bayes search?
Yes,
Yes.
I am.
So if you apply
Yes, sir.
Bayes search
Log
in
m.
one row, it will be log
Log m.
m.
Yes, sir.
Okay. So if there are total n rows, then what will be the time complexity?
And log m.
Okay. So can you do something much better than that?
Much better than that.
Yeah. Can you do something more optimal than that? Than buying search? Can you do it in linear complexity? That is what I'm asking.
I have to do in linear complexity. Okay.
Yeah.
Just
See, you told a brute force approach for it, correct? Then you also
yes,
told about a Bayes search approach for it because it was so
yes.
every row was sorted, so you applied Bayes search indirectly. Now I'm asking that can you optimize it furthermore to linear and bring down the complexity to linear approach?
That's a linear time complexity. Means I have to.
You can think about it or whatever is coming in your mind in terms of much more optimal strategy. You can tell us.
First occurrence. The right direction. Think.
Guys, you if you have liked the up till now, it's been almost 51 minutes. If you have liked the problem set, you can give us a +1 in the chat. If you have at least, it was a good practice for all of you who have joined us as the audience. You can give us a +1. Okay,
First step.
and you can hit the like button as well because we are very close to the end.
Yes.
So you want to think about this
Yeah.
question, or you want to? Yes, you can tell me.
So, so what's one thing I have to ask? Like the best approach is binary search only.
There is something more optimal than that. I'm saying that you
More
can do it in
optimal,
linear time.
and I can go to linear time. It is more optimal approach than binary search. No?
Yes, like my search will take almost n log m, na?
Log
But
m, n log
linear will take something like n plus m kind of complexity.
n plus n time kind of.
Yes.
Yes, sir. One approach I get.
Okay. What
So,
approach comes to your mind now?
so my first approach come to my mind is that by combining that sorting thing and that column, which I have tell you that first occurrence one, combining these two, I can think of an approach which will take very less complexity, like only take the complexity like which is that number of columns only. So, firstly, I will
Okay.
see the firstly I will iterate to first only in the I will search in first column if there is any one in the first column, as
Okay.
you can see 0 1 1 0. Yes, sir. as as soon as I see if there is one, so
Okay.
I will declare that like in this case I will say like in the second index one is occurring, so there will be most number of ones in the second in that second row,
Okay.
and that so we didn't have to search that whole that
Okay.
in that number of
So
I
you are
can
saying that you are basically saying that you will be when you will be the first row, then you will be starting from the last column in the first row, correct?
I give whole first column. We will start check the check first element of each row, and if we find in any row there is one in the first row, so we will say that that row has maximum number of ones.
But in the worst case, what will be the time complexity if there are a lot of zeros?
So if that's for example, sir, if the whole matrix filled with zero, that will be
You still have 5 minutes. Will you like to think for this problem, or you want to think for the
sir.
previous problem, some optimal approach for the previous problem as well?
Okay, sir. So can you another thing like which approach should I think about it? Binary search better.
Okay. Okay. So see, what I'm saying is, if you have been, audience can also carefully listen to this. See, if I have been given this particular matrix, okay, let's say I've been given the example one. So in that case, what I can do is I can start from the first row, last column. Okay. Are you getting my point? I can
Yes,
start
sir.
from the
I
first row,
like
last column.
like
Okay, it is
the
what? It is 1,
yes, sir.
correct? It is 1. Then in if it is 1, then I'll move back. So I'll in the same row I'll move to another column. So after that I move to this to the which element? To the third element. That is also 1. In the first row, the third element is also 1. Correct?
Yes, sir.
So in that case, what I do is I again move back.
Yes, sir.
So in that case, I move to the second element of the first row. Correct?
Yes, sir.
Then when I move there, so there is a 1. Okay. After that, I move back again. Okay. So up till now, I have stored that, okay, this first row still has the maximum number of ones. After that, I
Yes,
move again back. So after that, I move to the 0. Correct? That is the first row, first column. I move to the first row, first column. Correct? That is
yes,
0 0 index, and at
yes,
that point the element is having 0. Now this row has how many ones? Actually it has 3 ones. Okay, so now for any other row to beat it, it should have that particular column. It should have that particular column as 1. It should have
yes,
element
sir.
at that particular column as 1. Are you getting my point? Because if you
Yeah,
see, this row is exhausted. Now when you go to the other row, okay, now why can you take this for granted? Because the rows are sorted. When you go down to the next row, then that particular row, the second row, does not have that particular first element as set. Okay, the first element is not 1. So that means the second row is not having more number of ones uh,
yes,
compared to the first row. Correct? So in that case,
yes,
you again move down. When you move down, okay, when you move down again, then what will happen? When you move down to the third row, then the first element in the third row is set. Are you getting my point?
yes, sir, yes, sir.
So in that
Now,
case, if it is set, so this basically indicates that if it is set, and since the every row is sorted, so in that case, if this element is set, then that means all the elements towards the right is also set. So now this is the another maximum, right? This is the row with the maximum number of ones. Are you getting my point? So now you will
yes,
store this row, and then if this is 1, then you will again move 1 column back. So when you move 1 column back, then you end up what? Then you end up
out of
exceeding the out of bound. Okay, and you will simply say that this particular row has the maximum number of ones because it has all the ones, right? Are you getting my point?
yes, sir. So
So
I
that is
think
how in
yes,
yeah.
sir.
So
I
if you
think
will think,
about
so
that.
from top to down you are moving in m directions, like m indices one by one. Like see, from top to down if you are moving one by one, so n, order of n complexity, right? And
Yes,
similarly at the same time, also maybe you are moving in the leftward direction as well in every column, almost. So that's nothing but order of n plus n.
yes,
Okay.
yes, sir. I think
No, no,
about that
no.
approach, but I've not combined that two approaches. And like I am searching from last to first, but I have not combined that two approaches. Thank you, sir.
Actually, Priya, but like Maji is saying that my complexity is n cross m, but actually it is not so. What I'm saying is n plus m only. It is not n plus n cross m, because I'm saying that if you have discarded some people, then you will not check them back again. So I'm not checking all the cells. You have to understand this. Okay, it's
Yes,
n
yes, sir.
plus m.
Now understood, sir. Now
Okay,
understood, sir.
so all of you, like see, okay, so now okay, great. So now one thing, like all of you can give us a give a +1 and hit the like button. Give us a +1 for Anupam. At least he tried a lot, and he was very good. Almost he was very good with buying search. Maybe he felt a little bit pressurized because the problems were unseen to him. He had not seen this problem earlier, maybe, or this kind of problems. But all of you can give us a +1 in the chat for his effort. Okay, a plus
Thank you,
one,
sir.
at least he tried, because it's very difficult, to be honest. And some people, you can say that like Arnab was saying that it was asked in his interview as well. So all of you can quickly give us a +1 for his effort. Okay, great. Like Anupam, I would say that still you have started. You are in which year, Anupam?
So third year, sir.
Okay, so since you have still started your third year, so how long you have been coding? You have just started now?
No, sir. I have know the binary search as well, sir. But like I have done it very long ago, so forgot. Like I know all the approach, but coding is a little bit messed up. Like I have also, as you can see, like I have solved many number of questions in that. Like, but binary search I haven't touched from very long time,
Okay.
so that's the issue. Sorry, sir.
Okay, great.
Okay.
So in this case, like what I will suggest you is, you need to solve a lot of problems. You need to solve more problems, more variety of problems, and you need to solve matrices and all this stuff also. And today also you learn now applications of binary search. how you can apply buying search here, and how you can be more optimal. In fact, these two questions could have been solved without buying search, right, in more optimal time. So I hope that you
Sir, can
learn
you
from it.
please,
Did you learn from this lecture?
yes, sir. Sir, can
Yes.
you please tell the first one what I am doing then the first problem, what the thing I am doing
Okay, so
right there?
since see, Anupam, since we are a little bit out of time, so that is why I cannot tell you exactly about it. But in that question also, you will start from the first row and the last column. That approach you can try, but you can read the editorial for that. Okay, and I hope that everyone was benefited from this particular live stream. Yes or no? Like, did you like the question set for today? Yes. Audience can just quickly write a yes, because we are almost about to end this particular live mock interview. Okay. So Anupam, I just wanted to have your feedback, or like your viewpoint. Like, was it useful for you? Did you learn something from it? Did you found
Yes,
out
sir,
your weak
definitely.
areas?
Yes, sir, definitely, sir. Sir, I will find out that in the pressure situations, I have to practice in the pressure situation. Sir, I actually solved a lot of questions, but I am not trying that pressure situation of time bound. Like I literally solve
Okay,
for more time, like 20 minutes, 30 minutes per question, like this. So like I have to like there's a time pressure in that interviews and live, no. So I have to practice about that.
great. Okay. Vinay, you are saying that there was no variety. Actually, the both the problems that I took were very similar in approach. But if you want to see variety and harder level problems, then I will suggest you to watch some of the other mock interviews that I have recently taken. The last two, three interviews that I have taken, they have some good hard level problems. Okay. So this was it for today's interview, guys. Thanks a lot. I think Anupam's camera is on freeze because of some laptop issues, because of some
Yes,
technical issues. So this was it for today, guys. Make sure to hit the like button if you enjoyed this particular mock interview, if you learned something from it. And there's a form given in the description of this video. You can fill that particular form if you want to give the mock interviews with GFG. It's absolutely free of cost. Thank you for joining for today, and I wish Anupam all the best, and I wish all of you all the best as well. Make sure to keep
thank
coding,
you.
guys, and if you haven't liked the video, make sure to like it and subscribe the channel as well. Thank you, guys, and
Thank you,
I'll
sir.
see you in another mock interview. Yeah, thank you,
Thank you very
Anupam.
much, sir, for giving me this opportunity, sir. Next time I will definitely solve all the questions with you. I will also apply
Just
in the next
definitely.
time and le- I will solve all the questions. I will promise you, sir.
Definitely, you can come after a couple of months. After preparation, you can definitely come back. Okay.
Sure.
So thank you, everyone,
Thank
and good night. Take care.